Hi, my name is Jessica, and I'm an engineer at Qualcomm. And today I'm just going to be going over a proposed design for a simulated DSI panel driver to help validate various DSI host devices. So in this talk, I'm just going to go over a bit of background, some DRM framework background for DSI panels, some background on SimPanel in general, a very quick sidestep on the version history, then the current driver design, and then future work for the SimPanel driver. So first off, just a bit of background on how DRM framework handles the DSI panel probe and attach sequence. So usually most DSI panels are probed on boot up, and what happens is that first, when the DSI host driver is being probed, it'll register itself using the MIPI DSI host register API. And in that API, the MIPI DSI framework will go through the each child node of that device tree node, and it'll register that child as a MIPI DSI device. Then during the DRM panel probe, the DRM panel will first add itself to the DRM panels list, and then it will attach itself to the host as using MIPI DSI attach. And then as part of that, that will trigger the DSI host to be added as a component for the overall DRM display driver. So during the component bind for the DSI host, the DSI host will grab the DRM panel through a series of OF API calls, and then it'll attach that DRM panel as a bridge to the DSI host. So as you can see, there's a lot of dependency on the OF API, and thus a dependency on the DRM panel being defined within the DT itself. So basically, right now, the way to validate various DSI host configurations is to actually have the physical panel with the configuration you want to test. So there's a lot of disadvantages to this way of validation. It's not very scalable. It's also pretty logistically inconvenient since it's really hard to have every single panel that represents every possible configuration for a DSI host. And also, on top of that, not all panels are readily available to the public. So it can be hard to test some specific configurations. One example of this is just how command mode and video mode are validated for DSI drivers. The MSM DSI driver is one of the few drivers that's regularly validated using command mode panels. And most other DSI drivers will be validated with video mode panels. This causes a pretty big hole in the test cases being validated, since a lot of major mobile SoCs will actually ship with command mode panels, and also with some pretty complex features like the ability to dynamically switch between command and video mode. So in that case, why not have a panel driver where you can simulate a DSI panel? So that would allow us to test configurations, DSI configurations, where we don't have the physical panel available to us. And not only that, with SimPanel, you can actually adjust for panel configuration and catch DSI bugs on the fly without actually having the DRM panel driver available. You can also integrate this into CI, and you can use this to batch test panels and even do better regression testing. And on top of that, the Qualcomm downstream has already been using simulated DSI panels to do validation for the past 6 or 7 years. On the right-hand side here, I actually have an example of a simulated panel DT node. Unfortunately, we can't just port this one-to-one into upstream, since the SimPanel doesn't have any hardware resources, so we can't add DT bindings for this. And in fact, that was knocked when we asked the bindings maintainers about this. So another alternate that people might ask is why not use EDID? First off, EDID unfortunately doesn't support a lot of DSI configurations. So with EDID, you can't really specify DSI mode flags, DSC information, or other compression algorithms. You also can't specify the number of DSI lanes, etc. The DRM framework components aren't created without a panel being probed either. So you might not even be able to load an EDID and configure the DRM before a panel is actually probed. So yeah, aside of with the version history, so initially when we added the sim panel driver, we specified it as an MSM specific driver. So basically, you can only enable it with the sim panel enabled MSM command line argument. And also initially we wanted the user to be able to configure the sim panel via module parameters. We got a lot of great feedback from this first version. And just to summarize, the feedback was basically using module parameters was not very scalable and it's not very user-friendly either. So the suggestion was to switch to using the config.fs API instead. So now onto the current driver design. So right now the SimPanel series is kind of split into two parts. The first one is framework changes. So as I said in the very beginning, the real panels are very dependent on OF APIs. So we had to add a few SimPanel specific APIs to sidestep all this OF dependency. So if the SimPanel module is enabled, instead of going through each child DT node, the DSI host will register the SIM panel as the sole DSI device for that host. And it'll just hardcode the SIM panel information instead of grabbing it from the OF node. And for the bridge framework, instead of finding the panel or bridge via an OF node, we'll just find it by the driver name. And the second part is just the SimPanel driver itself. The MIPI DSI driver ops are pretty similar to that of a real panel. The major differences are just like how and when the panel is probed, and then also the config.fs. So the SimPanel can't be probed on boot up. You actually have to probe it explicitly yourself via a config.fs node. So in order to set up the sim panel, you first have to create the module by doing mod probe on the panel simulation kernel module and mount the config.fs. The user can then create like a test panel config.fs group and then configure these two nodes. So the first one is the modes node, and that's just to specify the supported DRM mode. The second is the mode flags node, and that's to specify the DSI mode flags. The user will then enable the SIM panel by passing in the DSI host device name to the enable node, and that will trigger the panel probe. So all in all, this is basically how the probe and attach sequence goes. When the DSI host driver is probed, it will just register the SIM panel as a DSI device. After the device boots to shell, the user can do the setup I described in the last slide. And then after they trigger the enable, that's when the panel will be probed and the panel will be added and attached to DSI. And then during the DSI bind, instead of doing all those OF API calls, it will just do the SIM panel specific framework calls. So yeah, this is just a summary of how to use the SimPanel config.fs. Like I said, you first have to mod probe the module, then mount the config.fs, create the panel group, configure the config.fs nodes, and then enable the SimPanel. Yeah, so there's definitely a lot of work that still needs to be done for SimPanel. First off, adding way more configuration options. We'd like to add the ability to specify multiple supported DRM modes, the ability to configure DSC, specify panel DCS command length, specifically since sometimes devices might operate in different modes depending on if it's a larger or smaller payload. And then finally, the ability to configure it so that a panel can be controlled by multiple DSI controllers. And then if all these configurations get complicated enough, we might even add eBPF support for SimPanel. And yeah, if this is interesting, I suggest you follow the current discussion around this series on patchwork, the DRI Devil, the DRI Devil mailing list, or yeah, feel free to come up and talk to me about SimPanel. Yep. Any questions?
I was just curious if you said this data isn't in the EDID structures. Do you know if it's present in things like display ID or successors to EDID or EDID extensions or anything like that, or does it just not make sense because you don't have the same auxiliary transport to get it?
So overall, the EDID can be helpful in describing like the supported modes for DSI. And in fact, in the Qualcomm downstream, there is some API, like uh, there is some way to represent like the supported DRM modes as an EDID. The issue is just that the EDID can't represent all of the DSI configuration aspects. Yeah, so you can't have just the EDID and use that to configure a DSI host. All right. Yeah, thank you so much.